welcome to this section. We'll be looking at quadratic graphs and plotting quadratic graphs from equations in this section. So, as I've told you already, when value of a is positive, we get a smiley face shape. So, in this case, if you've been told this is the graph for this equation, you take 1 and you put it inside the bracket. So you'll have x minus 1 and x minus 2, and you multiply those brackets and you end up with the quadratic form of the equation. Now, we've also been given the fact that it crosses the y-axis at 3 and it has minimum of 4. So, kind of situation, you can just check your answer. So x minus 1 times x minus 2 will give us x squared minus 3x 2. Alright, so when we substitute, this should have been a x plus 1 because the root of the equation is actually at minus. There's a minus sign missing there. So when you multiply the bracket here, get a negative 2 there, and actually a plus, plus negative x. So let me rewrite it. X squared minus x minus 2. Alright, so when you substitute a value of 0 into this equation, you should end up with a minus, no, there's a mistake there. Come to this section of the course. Here we'll be looking at how to plot graphs of quadratic equations and solve problems using those graphs. Okay, so let's look at the first example together. We've been told to sketch the graph for y equals to x squared minus 5x plus 4. First of all, you can say, I need the x and y axis, so let's just put labels on the x and y axis. So then in part 1, they say find the y-intercept. Not all questions will give you a hint as clearly as this. Y-intercept is always found by using x equal to 0 and substituting that into the function. So you get a value of 4 for y. This 4 is positive, so it tells us that it will cross the y-axis at somewhere above the x-axis. So then you also notice that there is the sign in front of x squared is positive. That will tell us that the graph will look like a smiley face. So there has to be this a smiley face or this kind of a smiley face. So let's see which one it is. If you factorize the equation, you'll figure out what the Let's factorize it. So this is what we found for part A. Now we're answering part 2, where it says find the roots of the equation by setting it equal to 0. So roots of the equation are found by factors of 4. So factors of 4 that add up to minus 5 are minus 4 and minus 1. This will tell us that the solution to this problem is x equals to 4 and x equals to 1. So both of roots will be positive. So we'll have a smiley face on the right side of this y-axis. Then we've been asked in part 3 to figure out the minimum point for the x-code and or rather the turning point. Alright, so for this part you could complete the square form and figure out what the value is, but a quicker way to figure out the minimum point is also taking the roots, adding them and dividing by 2. So notice the root here is 4 and 1. If we add them and divide by 2, we get 5 over 2, which is 2.5. So the equation at when you substitute the value of x to be 2.5, you end up with actually y value being negative 2.25. Alright, you could have also found this by completing the square, but to save time, this is another way of doing it. This form is not always possible, and this trick is not always to do, no, is not always possible to do. So make sure you do learn to how to complete the square in general. All right. In this next question, we have negative 2x squared in the middle of the function. So don't forget that this power of 2 is the most important part. This is telling me that it will have a dome shape, or rather sad face, like someone's not so happy. The graph will look something like so. We've been asked to find the y-intercept by using x equal to 0. So when we substitute 0 for x, 4 is multiplied by 0, and minus 2 is multiplied by 0, and we'll get simply negative 3. Right. Then in part 2, we've been asked to find the roots of the equation. So trying to factorize it, or either by solving the quadratic, the completed the square form, we can figure out the roots of this equation. Now, you should also be familiar with quadratic formula, where we discussed this earlier. So using the quadratic formula, we can figure out that the roots are. All right, let's go back uh, and see that actually this function doesn't have a root at all. Trying to factorize it doesn't always work. You can test it and you'll see that you will actually have minus 2. Let me show you that there are no factors that will satisfy this equation. We can take this minus 2 and multiply it by minus 3. So we'll get x squared plus 4x plus 6. Now, 6 does not have factors that add up to 4. Factors of 6 are 2 and 3. Plus and minus signs will not help us. So no factors here. We can try to solve it with quadratic equation, but notice that you'll be wasting your time, because I know the discriminant, which we'll be discussing in the next section, is the part that goes under the square root. The discriminant for a b squared minus 4ac should be positive, but it's not. Let's take the discriminant. This is the value of b, this is the value of a, this is the value of c. Alright, so when you substitute b minus 4 times minus 2 times minus 3, you'll have a positive 6 here and a minus 24. So 16 minus 24 is actually minus 8. So because the discriminant is negative, we cannot actually take a square root of a negative number, which this is impossible. And that's telling us that there is no point where the graph will cut the x-axis. Why is it? Because when we complete the square, we notice that actually this graph will look something like so. It will have a turning point below the x-axis, and it will never reach the x-axis. Let's complete the square and see what the square form is, what the turning point is. So we have negative 2x squared plus 4x minus 3. We can factor a minus 2 out of this part, so we'll have x squared minus 2x. Alright, and we leave the 3 alone because 3 doesn't have a factor of 2. So then inside this square bracket, I'm going to complete the square. I'm going to divide that 2 by 2, so I'll have a 1, and I'll subtract 1. Alright, so that tells me that when I actually drop the square bracket, I'll have x minus 1 squared, and this minus 2 multiplies by this minus 1, and I will get a plus 2. Plus 2 minus 3 together gives us minus 1. So we'll have x minus 1 squared minus 1. This is telling me that y value will be -1, and this bracket is telling me x will be at +1. Alright, so the turning point will be somewhere here, where x value is 1 and y value is -1. So you will have this sort of a shape. Okay, so let's look at the next part of the question. So if you actually notice that taking the quadratic formula wouldn't have worked because we have a negative square root here, and the notes here say that cannot be solved with any uh, such equations. Alright, so we completed the square, and we found that I did this by hand in the previous slide, and we found that the turning point to be -1, -1. When I multiply the -2 by -1, I actually get a +2. So +2 minus 3 is a -1. Alright, so in this question, we've been asked to figure out the equation of the quadratic, given the roots of the equation are -2 and -3. Now, in this example, you'll learn about something called the stretch factor, which is we deal with this stretch factor in more detail when you look at translation of and stretching graphs in later chapters, but it's good to understand it anyway. So when you take the roots of this equation and you write it as x equals to -2 and x equals to 3, you can put them back on one side and write x plus 2 equals to 0 and x minus 3 is equals to 0. Then you would have put a round bracket around these factors and you can multiply it. So let's see what happens. So when you put a round bracket around them and multiply them, you get x squared minus 3x plus 2x minus 6. Now, this is the combination of these two terms is a minus x. I've gone ahead and actually introduced a scale factor k here. I'm putting a bracket around the whole equation, and I'm saying that I need to figure out what this k value is. How do I do that? With another coordinate from the graph. What is this intercept? Is -12. I can read it from the axis here. If -15 is here, that's -14, that's -13, -12, -11, and so on. So when x equals to 0 on the y-axis here, x is 0, y value is -12. I'm going to substitute this coordinate into this equation here. So I will get k multiplied by 0 minus 0 minus 6 is equals to -12. Now solving this equation will tell me that k value is actually a +2. This +2 needs to be in front of this equation that I found on this line. Alright, so I'm rewriting this line again with the value of k that I found here. And I'm going to multiply this whole equation by 2. This is a stretch factor that affects this equation. Yes, the roots are still -2 and 3, but it's been stretched in a factor in a y direction by a factor of y. So here are some extra examples where you can pause the video and have a go at them, particularly this question here and these questions too, and then unpause the video and I'll show you the answers. Alright, the answers are here at the bottom of the page. You can check it. These are also some questions from another book that I found. You can find the quadratic form of the equation from the graph. This particular example is where you have a repeated root. Alright, so If I show you how it's done, you will have x minus 3 multiplied by another x minus 3. Now, in this particular case, it looks like the stretch factor is a 1. So it's important to know what the stretch factor is because you'll use it in other of the book as well. All right, happy practicing. I'll see you in the next video.